Hi everyone, welcome to this class. We shall be discussing about capacitance, where we will say capacitance is defined is a device, or capacitor is a device that is used to store charge. Basically, before we talk about capacitance, we need to understand what a capacitor is. So we have said a capacitor is a device that is used to store charge. And remember, charge is denoted by letter capital Q, or sometimes you can denote it by small q. And then the charge stored Q in a capacitor is given by this formula. Remember, we know current is the rate of flow of charge. So we are saying the charge stored by a capacitor is given by the product of current against time. We normally say current is the rate of flow. Current I is the rate of flow of charge per given time. So current is given by charge flowing against the time. That is why if you cross multiply, you will get Q is equal to I multiplied by time t. So basically that is how you get your charge. We have done that some time back, and I think you can be able to remember and reconnect. We move to the next point where we say where capital I is the current in amperes, and T, this small t, is the time in seconds. So whenever you want to calculate charge Q, remember or bear in mind the current I has to be in amperes and T has to be in seconds. You have to express them in the SI units. Another point is the SI unit for charge Q is coulombs. It is coulombs. Remember, when you are writing this word coulombs, C is small letter, but if you want to denote it, you have to denote it using a capital C. So if you are writing the full word, the C has to be a small letter, but if you want to denote it, then C has to be capital. C has to be capital. So having said that, we now want to look at the properties of a dielectric material. What is a dielectric material? First of all, you need to understand a capacitor is a device which has two plates that are separated by a given material. So there is a material that is in between these two plates. This material can be air, it can be any material. So basically, we are trying to look at the properties of the material that is put in between the two plates, so that now this capacitor will be able to store charge. So basically, when we talk about the dielectric, so this material that is put between the two plates to form a capacitor is what we call a dielectric. So dielectric is the material that has been put between the two plates to enhance the storage of charge in that particular device. So those are the properties that we want to look at. Those are the needs that we want to look at, so that we understand the real properties of this particular dielectric material. The first one, it should have high resistivity to reduce the leakage current. Remember, we have said this material has to store charge, and for charge to be stored, current does not necessarily have to flow from one point to another. So we need this charge to accumulate. We need this charge to be stored. So the material that we are going to put here should not allow current to flow. That is why we are saying point number one, it should have high resistivity to reduce any flow of current. The second point is it should have high mechanical strength. Should be having very high mechanical strength. Number three, should have high dielectric strength. That is another point. Number four, should have low dielectric loss, meaning the losses should be very minimal to ensure that we are saving as much charge as possible. Remember, in an ordinary battery, like the battery of your phone or any other battery, it has several capacitors lined up for storage of the charge. So when you are charging your phone, basically it means you are storing charge. So a very good example where a capacitor is applied is when you are making up those batteries. They need to be having this kind of capacitors to enhance the storage of the charge. So that is why we are saying it should be having very low dielectric loss. We move to number 5. Should have a low water absorption quality, meaning should be a material which does not absorb water, because if it absorbs water, then it's going to compromise the quality or the capacity to store. Number 6, should have low thermal expansion. That material should not be a material which can easily expand or contract. The material should remain in its position without being affected. So basically we are trying to say this material should not be so much affected by the atmospheric or by the external conditions like temperatures and the rest. Number 7, should have high thermal conductivity is another point. We now want to look at what capacitance is. Remember we said our topic, our major subtopic is capacitance. We began from what a capacitor is, and we have said a capacitor is a device used to store charge. We now want to look at what is capacitance, because capacitance is associated to capacitors. So capacitance is the ability to store charge, the capacity to store charge. So if a capacitor has got a big capacity to store charge, then we say the capacitance of that capacitor is very high. So capacitance is a measure of the amount of charge the capacitor can store when connected to a given voltage. So capacitance defines or describes the amount of the charge that given capacitor will be able to store when it is connected to a given source of voltage. It can also be defined as charge stored per unit voltage. This other definition will assist us to come up with the formula. We are saying it is defined as the charge stored per unit voltage. Remember our earlier definition was it is a measure of the amount of charge the capacitor can store when connected to a given voltage. So we can say capacitance, which is denoted by letter C, is equals to capacitance denoted by C is equals to the charge per unit voltage. So meaning capacitance is directly proportional to charge but inversely proportional to voltage. So we have said capacitance is the charge stored per unit voltage. So how much charge will be stored when you are having 1 volt? That is basically what capacitance is. So it is the ratio between the charge stored against the voltage of that particular circuit. So having put up all those definitions, we now want to move deeper into the formulas. I've said capacitance is given by the charge stored per unit voltage, and obviously you know Q represents charge, V represents voltage. So what is the SI unit of capacitance? The SI unit of capacitance So capacitance, the SI unit of capacitance, SI unit of capacitance, C, is given by farads. The SI unit of capacitance is farads. I said if you are writing the full word, you write the first letter should be a small letter, but if you want to denote it, you'll use capital F. So you will find you are given 20 F. 20 F means these are 20 farads. 20 farads. So we want to look at sometimes in an exam you can be asked to define what a farad is. Very many cases I've seen people being tested to define what a farad is. We can say a farad is the capacitance of a body if a charge of 1 coulomb raises its potential by 1 volt. So farad is the capacitance of a body. You can say if you are defining farad, a farad is the capacitance of a body if a charge of 1 coulomb raises its potential a farad is the capacitance of a body if a charge of 1 coulomb raises its potential by 1 volt. Is a very key definition that you will get in most exams, that you're asked define what is a farad. What is a farad? So we have said a farad is the capacitance of a body if a charge of 1 coulomb raises its potential by 1 volt. So always you have to bear this in mind. We want to look at various expressions because a farad is a very big unit. So in most cases, in most calculations, you may find an examiner giving you expressing this farad in smaller quantities. For example, we can say 1 microfarad. We can use 1 microfarad is the same as 10 power negative 6 farads. So if an examiner gives you 1 microfarad, what you do, you have to change this value by multiplying it by power negative 6. You can also be given 1 nanofarad. Nano means, remember, micro comes from the word a million, So micro goes hand in hand with 6 because a million has got 6 zeros, so you use 6. This one represents nanofarad. Nano comes from a 9-sided figure, so it will be 10 power 9 farads. And another one, you can also be given 1 picofarad. Pico in this case represents power 12. It will be equal to power negative 12 farads. Power negative 12 farads.